Welcome to Lecture 2, Part 1, where we're going to look at the plasticity of clay soils. Carl Terzaghi, another well-known soil scientist, once said, "Unfortunately, soils are made by nature and not by man, and the products of nature are always complex." So this lecture series is again broken into two parts, and we're looking at Craig lecture 1. Or paragraph 1.3 and 1.4. In the first part, we're looking specifically at the plasticity of clay soils. In this lecture series, we will start getting some equations and definitions. And throughout this course, you will find there's a lot of definitions and abbreviations, as well as a lot of formulas and equations that you need to know. For the exam part, I will present you with a formula page that will have all the formulas that you would need in order to do the work. But I would suggest that you start making yourself a list of definitions, because we are going to deal with a huge number of definitions and abbreviations. What is the plasticity of clay soils? It describes the cohesion of the clay soil, or the apparent cohesion at least. So it describes the strength of an unconfined clay sample. This strength is due to the negative pore water pressure. When the water above the water table, the water is held by the capillary tension, so the ground is unsaturated. This is causing the strength of the clay, because the water sticks to the particles due to negative pressure, and the particles are pulled closer together, and that causes the friction between particles. So the strength of the clay is lost if you immerse the clay in a body of water. A sandy soil can also have an apparent cohesion, but pores are larger, and therefore it has a weaker cohesion. True cohesion is derived from electrostatic forces as well as cementation between particles. So if the clay has undergone or has moved further along the path of becoming cemented or becoming a rock. Plasticity is the ability of soil to undergo irrecoverable deformation without cracking or crumbling. And the soil can be in 1 or 4 phases depending on the water content. It can either be a liquid or plastic, semi-solid or solid. So if you reduce the water content in the soil from the liquid phase, the soil goes from a liquid to a plastic, semi-solid and solid. The soil is plastic due to significant presence of clay minerals, and the water in the voids between the clay particles are held at negative pressure by capillary tension. So the soil can be molded and deformed. If you look at this graph, on the left-hand side, you can see the volume, and the bottom is the moisture content. And as the moisture content increase, then you have an increase of volume. So you have a solid material. Then if it goes past the shrinkage limit, which we will define just now, then you get a semi-solid. Then you have the plastic limit. Then it becomes a plastic moldable material. And then eventually, if you pass the liquid limit, then the soil effectively behaves like a liquid. So the liquid limit, WL, is the upper limit of the range of water content over which the soil exhibits plastic behavior. So it's the upper limit. After that, it acts like a liquid. The plastic limit is the lower limit of the range of water content over which soil exhibits a plastic behavior. You look at the previous graph, this will explain it also. Then the plasticity index, it covers the water content range. Now the plasticity index, IP, is defined as the liquid limit minus the plastic limit. But in many parts of the world, but especially South Africa, you will very seldom see the term IP. You would rather see the term PI. So PI and IP is the same thing, and it's the liquid limit minus the plastic limit. So in the exam and in your future life, you will probably hear the word PI more often, and therefore it's interchangeable, and I will accept it as a valid expression for the plasticity index. The liquidity index, that's the natural water content relative to liquid and plastic limits. So the liquidity index is the water content minus the plastic limit divided by the plasticity index, the IP or the PI. The shrinkage limit is the water content at which the volume of soil reaches its lowest value as it dries out. After that, there is no more water, and it becomes a solid, dry piece of clay. The activity of clay soil is very important, and as I mentioned previously, we will look at it a lot. And activity describes the potential of clay soil to undergo volume change when the water content is changed. So it can either swell if it's dry and you add water, or it can shrink if you let it dry out. And it is the ratio of the plastic index, the PI, to the clay fraction. So the activity of the soil, as it dries out, you can see what happens in a road made of clay material when it dries out. It's devastating, and obviously has huge consequences for roads and buildings, etc. The one way that we test for the plasticity of clay soils is some laboratory methods to determine the liquid limit and the plastic limit. Please read the description of how the Casagrande cup works. It is in the handbook. I'll show you some pictures of what it looks like and more or less how it is used. So this thing is called the Casagrande apparatus, or most people actually call it the Casagrande cup. It has a little cup that you put in the clay soil, and the handle sits on the left-hand side, and you turn it anti-clockwise, because this helps you to keep track, because you have to turn it, the cup will lift a little bit and then drop for 25, what we call 25 ticks. So you turn it 25 times, and this cup will go up and down, up and down. You mix the soil with a little bit of water, and then you take the little tool that's shown on the left-hand picture, and you draw a groove through the clay. Then you turn it 25 times. If the soil is too dry, then it will move, but it will not touch. So once you reach the liquid limit is when you've added enough water to it so that after the 25th turn, the bottom of the groove is just closed up. Then you take the soil and you test the water volume, and then you know what is the liquid limit. Then the plastic limit test is done again by taking a piece of soil, put some water in it, start making these little worms, and you roll it out in a thin line, and the moment it starts breaking, then you know that is the water content of the plasticity index. The plastic limit test is done in this way, but it is nicely described in the handbook, so please read through it so that you can understand. This is a test that you probably will perform in your career, and also next year in Geotechnic 354.